Hello, everyone. Technology is crazy. Hopefully, this works and can answer some questions about the quiz from Friday, which hopefully I also will have a chance to grade today. All right, and just go from the top. Hopefully, I can see the function definitions also. All right, so it's starting by asking us f of 2. So this, I think we know how to do. We're going to plug in 2 for x, right? It's asking us the value of f when x equals 2. So I'm going to plug in a 2 right here. Evaluate this. 7 plus 10 over 5. 7 plus 2. That's 9. Similarly, with g of 150, that's 1. Ignore that. 1 minus the root of 150 minus 6. Obviously, pick this so it would be a perfect square. 1 minus root 144, which is 1 minus 12, which is negative 11. All right. Actually, let's do e now, and then come back to the ones that have to deal with h. F of g of 42. So first, let's find g of 42, which is 1 minus root 42 minus 6. That's 1 minus root 36, which is 1 minus 6, which is negative 5. And then f of negative 5 also works out to not be too messy. 7 plus 10 over negative 5 plus 3, which is 7 plus 10 over negative 2. That's 7 minus 5, which is 2. All right, for h, right, h I think was giving a lot of people trouble because it was not written algebraically with x's and, as an expression, but only graphically. It's important to realize that a function is like the y value. For example, when it asks me h of negative 2, it says when x is negative 2, which is over here, right? What is y? And that, right, when x is negative 2, what is y? And that point is right here. When x is negative 2, what is the y value of h of x? It's negative 1. That is really, I think, the most important takeaway, to realize that you can read a function graphically by saying the output, right? When you put in x, what value of the function do you get is the y value, and we can find that graphically by seeing, well, when we go to x being negative 2, we get a y value equal to negative 1. Similarly, g of 15 over here, we can do that. And h of 1, right, I'm just plugging in 15 for x in the definition of g, and h of 1 is similarly, when h is 1, when the x of h is 1, here's where it gets tricky. This is a hole, right? This point is not on the function. When x is 1, the y value of h is this down here, negative 3. You might think that there are 2 points, but right, it's a function, it passes the VLT. This is the hole. This is the point that is actually in the function. So when x is 1, the y value of h is negative 3. So we can plug in negative 3 for that, and then this we can evaluate. 1 minus root 9 minus negative 3 is plus 3. 1 minus 3 plus 3 is 1. Alright, that, I think, if you still have questions about looking at the graph, that is really the thing to focus on and ask me about. Alright, the domain of f of x. Talking about domain and range, the x values that are allowed and not allowed. You cannot, right, because of this, I'm going to run out of colors, because of this 3, x cannot be negative 3, because we can't have a denominator of 0. So x cannot be negative 3. The range, this is trickier. When we have fractions in our functions, this is always the way you're going to think about the range. This fraction, right, this whole fraction can never equal 0. because it's 10 over something. 10 over any number is never going to be 0. The only way you could have a fraction equal to 0 is if 0 is the numerator, right? 10 over anything, it'll be some decimal, it'll be some, improper fraction, but it's never going to be 0. So if this can never be 0, we're never going to have 7 plus 0, right? It's going to be 7 plus something, either positive or negative, it's big or small, but it's never going to be 7 plus nothing. So the value of the function can never be 7, right? And we say the value of the function is the same as the y value. So the y value for f of x, the output, you can never get 7 out of it, no matter what value of x you put in. The range of g. The domain of g, I think we know how to do, right? The domain of g, we could say that for domain of g, we can say x must be less than or equal to 6, right? X can never be bigger than 6. It could be 6 exactly, because we can have a radical being equal to 0, but it could never be bigger than 6, because then we'd have a negative number inside the radical. To find the range of g, let's consider when x, is equal to 6 exactly, like the boundary case, this is going to be 0, the radical itself. So the value of the whole function is going to be equal to 1. But if x is, right, and if we go down from that a bit, right, if x is, if we go up, right, when x becomes bigger than 6, this radical is always going to be positive, right? The output of a radical is always positive. This could give us, if x was 7, we would have root of 7 minus 6 in here, that'd be root of 1. If x was, which is 1, if x was 10, we'd have root of 10 minus 6, which is root of 4, which would be 2. So the output of a radical is always positive, right? This is whatever x you put in, it gives you an always positive. So if it's going to be 1 minus always a positive, that means the highest number it could be is 1, right? 1 minus a half is a positive number. 1 minus a quarter is a positive number. 1 minus, not a positive number. It's going to be less than 1, right? 1 minus 10 is less than 1. It can be higher than 1 because I can't be subtracting a negative from 1. I'm always subtracting a positive from 1. So I could say the range is that the y value of g is always less than or equal to 1, right? It's equal to 1 if the radical gives me 0, but otherwise I'm subtracting a positive, so it has to be less than 1. To the next page. Alright, h of x. Let's talk about getting a domain only from a graph. The domain is the allowed x values. I see my allowed x values. This function goes between -3 to 4. That it really is everything. And I can write that as -3 is less than or equal to x, which is less than or equal to 4. X can be anything in between, it's a bad arrow, in between -3 and 4. Alright? Even though it doesn't give us a function, like an algebraic function, like it's not represented algebraically, we can see that the allowed x values for this function are between -3 and 4. The range is a bit trickier. On the bottom end, we can see -3. On the top end, we see 2. However, it is an open circle, so the y value can't equal 2, but it can go just less than 2. So, with this in mind, I'm going to say that -3 is less than or equal to y, which is less than 2. Not less than or equal to, because this is not a filled circle. It can approach 2, but it can never equal it. You might be thinking, well, what about this hole? like, can't we also not have a y value of 0 because there's a hole on 0? But we do, it's just over here. So you always have to look. Really only pay attention to the holes if they're in the, at the edge, right? Because we know this hole in the middle of the graph is going to get passed and filled in somewhere else. Right, zeros. 0 is what x value makes the function, which I'm just going to write as the y, equals 0. And the really important way to think about this is when y equals 0 on a graph, what do we call that? The x-intercept. And that is going to help us big time with h. We can also do this by solving. So, for f of x, the output to be 0, we're just going to plug in 0 for f of x. 0 equals 7 plus 10 over x plus 3. This we're going to solve. Move 7 to the other side. I'm going to need to write that smaller. 0 equals 7 plus 10 over x plus 3. Going to move the 7 to the other side. Negative 7 equals 10 over x plus 3. Multiply both sides by the denominator of this. We'll kill the denominator over here and put it in the numerator over here. Negative 7 times x plus 3 equals 10. Distribute negative 7x minus 21 equals 10. And add 21 to each side. Oh boy. Add 21 to each side gives me 31 over here. So negative 7x equals 31. X equals negative 31 sevenths. If you plugged that in, you would get the function to output 0, and you could check it by plugging that in for x and seeing if you really do get 0, right? Just checking that equation. It's 21. All right, g of x. It's going to have to solve with a radical. 1 minus root of x minus 6. Move the negative 1 to the other side. Negative 1 equals negative root x minus 6. How do we get rid of a radical? To sort of free this x from radical, we square both sides. Squaring negative 1 just makes it 1. Squaring this whole side gets rid of the negative and the radical. 1 equals x minus 6. X equals 7. We can kind of see that even simpler, right? Like if x was 7, this g would be root of 7 minus 6, which would be root of 1, which is 1, and then 1 minus 1 would give us the output g of 0. H of x. I said x intercepts. So let's take a look at that. What value of x makes the y value 0? It is the value of x that is the x-intercept. This is not an x-intercept because it is a hole. This is the x-intercept, and that occurs when the x value is a negative 1, right? When x is negative 1, the output y value of h of x is 0. There is no up-down-ness when x is negative 1. All right. The really, really tricky stuff. Everything was tricky. H of g of x. This is how I want us to sort of dissect this. This is asking what x value makes this entire thing 0, right? And here's how we can go about that. First, let's think of the h piece, right? And sort of answer. And think of just the h piece. And we're going to try to answer that now. What input does h need in order to output 0, right? That's what a 0 of a function is. What can I put into h that will give me 0 out? And we already know that from over here, right? We already know that I need an input of -1, because we learned that the 0 of h was x equals -1. An input x equals -1 gives me an output of 0. So we know that the input of h, right, the thing going inside h, needs to equal negative. We know that the input of h needs to equal -1. And in this case, the input of h, the input of h is g. So now what I'm going to do, the input of h is g, right? I need to put -1 into h to get out 0. We learned that from over here. And the thing I'm putting into h is g. So the question now becomes, setting, right, is answering, let's do a different color. What input does g need in order to output -1? Because if g outputs -1, and then we put that into h is going to output 0, and that is what we are trying to answer. So now we can solve this by setting, right, say, we're plugging in -1 for g. -1 equals 1 minus root of x minus 6. Let's actually move that all the way. So over here, -1 equals 1 minus root of x minus 6. Subtracting 1 from each side, -2 equals negative root x minus 6. Squaring both sides, 4 equals x minus 6. Adding 6 to each side, 10 equals x. So the answer to the 0 of this function, the thing that if I put it in will make the whole thing output 0, is an x value equal to 10. Alright, let's look at h of x. We're going to answer this again, right? Asking the same question. What input does the outer function need in order to output 0? Right? What output does the outer function need in order, what input does the outer function need in order to output 0? Would be an input of x equals -1. And then I'm asking my inner function, when is that equal to -1? That's the same thing we did above, except above we found out when g of x is going to equal -1 by solving and finding that that's when x equals 10. Here we need to look graphically. When does h of x equal -1? H of x equals -1, right? The y value of h of x is -1. The output is -1 over here when the x is -2. So the 0 of this whole thing is x equals -2. And if we wanted to, let's do this as a check, right? So h of -2, what is that going to be? Well, we see over here, right? H of -2, let's go to -2, and what do we get? A y value of -1. So this will now be h of -1, and then we're going to go to an x value of -1, and what do we get over there? 0, which is what we want. Alright, g of f of x. Alright, let's, there's actually something, if I'm remembering correctly, really cool about this, so I want a lot of space. Oh boy. Let's see if I can copy the rest of everything onto another page. Give me a sec. Like I said, I'm not great with technology. if this works, guys. But I don't want to copy it with all those markings on it. Oh boy. Well, we'll make it work. Whoa. No, that, I want to, oh, you can only let me copy ink? Alright, well, I'll just rewrite it. Okay. Sorry about that. Let's get some space over here. So this is asking us now, okay. Oh, well, we have, okay. What is the 0 of g of f of x? I'm just answering this over here because I want more space. This is this problem right here. Alright, first let's do it the normal way. Well, the way that we've been doing it. I don't know if anything in Algebra 2 is normal. G of f. So we're saying, what is the 0 of g? Right? What do I need as an input to make the outer function equal to 0? Well, luckily, I already know that from over here. Right? We already solved that. We already know that G needs an input of 7 in order to output 0. So that means that this thing must equal 7. So now we can plug in 7 for f of x and say 7 equals, right? Let's plug in that 7 for f of x. Say 7 equals what? What x value does f of x need to output 7? We can solve it like this, right? This is the definition of f of x. And now we can solve this. And this is where it's going to get crazy. 7 minus 7, right? I'm subtracting 7 from both sides. So 0 equals 10 over x plus 3. Now I'm going to multiply both sides by x plus 3, right? We already did this earlier. And get 0 equals 10, which is a no solution. This is somewhat complicated to explain, but let's think about it in terms of this. Right? The 0 of g is 7. So the 0 of g of f of x is going to force f of x to equal 7. But we already remember when we said, what is the range of f of x? It is never going to output 7. So that is why it makes sense that there is no solution to this. F of x can never be 7. So there is no 0 of g of f of x. What that means graphically is it would never have an x-intercept. There is no 0 of g of f of x. An cool thing otherwise, and I think this is worth doing. Remember we said if you want to generically find, right? Let's say in general, how could we express g of f of x? Well, we can take all of f and plug it in to x in g. So, right, g is, let me rewrite them here. G of x equals 1 minus root of x minus 6, and f of x equals 7 plus 10 over x plus 3, right? What I'm going to do now is take all of f of x and plug it in to the x in g. And you will see why I am doing this. So g of f of x equals 1 minus 7 plus 10x plus 3 minus 6. Alright, which is, let's simplify that for a second, 1 minus 1 plus 10 over x plus 3. Alright, right, that's from 7 minus 6 being equal to this 1. This is a really interesting thing to think about. Let's think about now the range of this, without even doing any more algebra. We know that a fraction can never equal 0. We have discussed this a lot. Now this never equals 0. And if that never equals 0, it means that, right, the whole thing in the radical, oh boy, we're getting into some, there's a lot of pretty colors here, guys. Oh, that this, no, I just used the blue. Oh, pink. Means that this thing, right, if the fraction never equals 0, I'm never going to have 1 plus 0, so this never equals 1. And if the thing inside the radical never equals 1, I'm never going to have square root of 1, which means, oh boy, orange, which means that the whole radical, right, I'm never going to have square root of 1, which means this never equals 1. And if that never equals 1, I'm never going to have 1 minus 1, which means the whole thing never equals 0. So g of f of x, which is this, can never be 0, which is also what we proved over here. There is no 0 of g of f of x. Crazy. Alright, back up to the last problem. A piecewise definition for h of x. So hopefully I can fit everything here. I'm going to answer this in the space we didn't use, just because, right, it's the space that I can still see the function. Alright, this is going to require me to write some lines, to write the equation of some lines. This first line, this is how I think the best way, right, we talked about this a bit. This first line, which is, oh boy, so many colors. This, well, I think we can all see. The first line, this diagonal line that I'm running the dot over now, that is the line x plus 1. It has a slope of 1, hopefully we can see, which means there's no coefficient of x. And then it's going to have a y-intercept at y equals 1. So that line is, right, we're answering this right now. X plus 1. And at what values of x is that happening? Between negative 3 is less than or equal to x, which is less than or equal to negative 1. Right, this is between the x values negative 3 and negative 1. My next line is the line negative x plus 1. It has a slope of negative 1 and a y-intercept of 1. That starts at the x value not at equal to negative 1 because of the hole. So x is greater than but not equal to negative 1, and similarly less than but not equal to 1 because of the hole. The last line is I always have a y value of negative 3, and that is when x is greater than or equal to, right, because it is a filled circle, 1, and then less than 4. That is how we write the piecewise definition of this. There's a lot going on in this quiz. I guess I'm going to grade it right now. Yeah, Shana Tova, everyone. Please ask questions about this. Meet with me I know we don't have Monday, Tuesday, obviously, but Wednesday, study halls. Thursday, I'm in math lab. Shana Tova, and everybody have a sweet New Year. And see if I can figure out how to end this.